Hello everybody. Our project topic name is finding point of deviation in a specific domain chat. We live in the world of social media where we get hundreds of messages, but they are some of them are important, some of them are not important. So what we are doing, we are finding a point of deviation in a domain specific chat, or you can say a spam message. So we have existing solution, existing systems like so. These are the existing system, and what we are doing, we are automating this. So we have a chat interface where user can send a message, and we are taking this message and converting into vector embedding with the help of SentenceBird. SentenceBird is an open source library, and we have a dynamic threshold to check whether this message is relevant or not. Now Rohit will explain you.
So thank you, Ashish. This is Rohit. Now let us discuss the flow of the algorithm. Let us assume in the system there are n number of users who can message. We store those messages in the form of queue. Now let us assume that the chat is running and we have sent ith message such that I is greater than k, where k is the window size. Now, when the message is sent, we need to merge previous k messages. For simplicity, let us assume k is 7. So basically, we need to merge messages from I minus 7 to I minus 1. Now, the task is to get vector embeddings by passing the merged message and also the current message through sentence bird. Now, we need to find the cosine similarity between the two vector embeddings. If the cosine similarity is greater than that of the threshold, we need to consider it as relevant and not spam and mark it as green. Else, we consider it as spam and mark it as red. Now, if the message is relevant and value of I is less than k, that is 7, we directly push the message and its cosine value into the queue. If I is greater than 7, we need to pop the I minus 7 message and push the new message in the queue. Now we shall discuss about how we set a dynamic threshold. So dynamic threshold will only change if the message is relevant. So let's remove the case of irrelevant message. Now we are storing the cosine similarities of previous k messages. To find the new threshold, we need to find the average cosine similarities and set the new threshold as average similarities minus average similarity into scale. And if the scale value increases, then there is a relaxation in chat message. While if we decrease it, the message must be stripped in the context. Now, Vaibhav will show the demo of the system.
So thank you, Rohit. Vaibhav this side. So now let us build up the demo. So we are initially assuming the ground truth to be true. So we have taken a paragraph from Wikipedia regarding malaria, and we are simulating a conversation between two doctors by sending each sentence as a message between them. So as you can see, our self messages are colored green and the other users messages are colored blue, and the cosine score is calculated below the screen, right? The bottom left. This is the dynamic score. Okay. So as you can see, the conversation proceeds and everything is currently relevant to malaria. Now we introduce a new user, say dummy doctor. Now he will talk something irrelevant like don't let go of free data. So he gets a warning message like please send relevant messages, and the message is turned out to be colored in red. So what exactly happens here is the threshold that is being calculated with the previous 7 messages. This irrelevant message cosine score is less than the threshold, and hence it is turned out in color red. But what about this message? It is something relevant, right? Like headache, crocin, it is relevant, but still it shows red. Why so? Because in the current context, because as you can see, because in the current context, this message is still not relevant. They're talking about malaria, but they have not yet reached the point where this message is relevant, like about medicine and stuff. So what we will do is we will diverge the conversation to that particular point where this message turns out to be true, and thus proving a point of dynamic thresholding. So we move forward in the conversation between the two doctors, and we make a diverge the point to that of the medicines. So as you can see, the doctors are talking about medicines, the cosine score is being calculated, everything is going well. And now we input the same message as before about the crow scene. And tada, as you can see, the message turned out to be green and blue in the other respective chat boxes. Hence we proved our point of dynamic thresholding, that the previous 7 messages are our history vectors that are used to calculate the threshold for a particular chat and for a particular context. So thank you from this is from my side, and giving back to Rohit.
This algorithm can be implemented as an extension in YouTube to filter spam messages in live streams and comment section. It can be used in other social media platforms as well. Thank you.